Now we have some properties for these even signals and odd signals. So let us see one by one. So here we have an even signal. Why we call it as even signal? Because it is having a vertical symmetry. Okay, vertical symmetry. Okay, this signal is having vertical symmetry because we can flip it horizontally with respect to the vertical axis. We will get the same signal. What about the odd part of the signal? If this signal is an odd signal, then it must be like this. It has a positive part like this, and in the negative axis it must have some part like this. Then only we can say that this is odd signal. So this green color signal is an example of an odd signal, but this property says that this is already an even signal. Because of that reason, that signal does not have an odd part, right? So since the signal is already even signal, that does not have an odd part, right? So even signal does not have an odd part. So that is the first property. Okay, so when a signal is even, then its odd part will be 0. Now let us go to the odd signal case. Here we have an odd signal. See, already it is an odd signal because we can see that it has a vertical anti-symmetry. Actually this will be an even signal if the shape of the signal is like this. Okay, we have seen in the previous property, right? If the shape of the signal is like this, then this blue color is an even signal, right? But already this pink color signal is an odd signal. So because of that reason, we can say that it does not have an even part, right? So we can say that when the signal is odd, then its even part will be 0. That signal does not have an even part, right? The even part of the signal will be 0. Now consider some signals which takes polynomials of this form, that is x square, x power 4. Then whether this signal is even or odd. To understand that, let us go to Desmos and plot that functions. So here y1 is equal to x square, right? So you can see that this particular signal has a vertical symmetry. So this is an even signal. Coming back to our presentation, this is an even signal. If the signal is having the shape of y1 is equal to x square, this is an even signal. y2 is equal to x power 4. So that is also an even signal because it has a vertical symmetry. So we can say that signals of this form, that is y2 is equal to x power 4, is also an example of even signal. Now what happens if I multiply y1 and y2? Otherwise, what happens if I multiply an even signal with an even signal? Now let us multiply that. That is y is equal to y2 into y1. Okay, so this red color is the result for y. You can see that that is also an even function, right? That clearly indicates that when we multiply two even signals, you will get the resultant signal also as an even signal. That is another property we have to keep in our mind. The product of two even signals is an even signal. Consider these signals which has the shape of these functions. y1 is equal to x cube and y2 is equal to x power 5. So let us plot that in Desmos and check. So the first case is y1 equal to x power 3. So you can see that this is having vertical anti-symmetry. So because of that reason, this is an example of an odd signal. So any signal which take the shape y1 is equal to x cube function, then that signal is an example of an odd signal. y2 is equal to x power 5. Here also this green color, you can see that is also an odd signal because it has vertical anti-symmetry. So you can say this is also an odd signal. So what happens if I multiply y1 and y2? Whether it will be an even signal or an odd signal. So let us again try to plot that. So here y is equal to y1 into y2. Okay, so you can see that the resultant signal is this purple color signal. So I will show that alone. I am hiding the function y1 is equal to x cube and y2 is equal to x power 5, and the resultant signal, you can see this is having vertical symmetry. So this is an even signal, right? This is an even signal. The product is an even signal. Okay, so that is another result or property we have. The product of two odd signals is an even signal. When we multiply two odd signals, the resultant signal will be an even signal. Now consider an odd signal and an even signal. What happens if we multiply an odd signal and even signal? We know that this is already example of an odd signal because this is x cube and this is x power 4. This is an even signal. Otherwise we can say that polynomials with even powers will be even signals and polynomials with odd powers will be odd signals. Now what happens if I multiply an even signal with an odd signal? So we already have y1 is equal to x cube here, and the other one is y2 is equal to x power 4, right? So this one is odd signal and this one is even signal. So if I multiply, what happens? Y is equal to y1 into y2. So you can see that the resultant is red color. Okay, I will hide the other signals. So you can see that is an odd signal. So we can say that the product of an even and odd signal will be odd, right? So the product of an odd signal and an even signal is always an odd signal. How can we construct an even signal from a signal x of t? So that is demonstrated here. It is equal to finding out the even part of the signal, finding the even part. Okay, finding the even part of a signal. How can we do that? So we have a signal x of t. It is plotted here. So the signal is looking like this. And what we have to do is that we have to reverse it. Okay, we have to reverse it and you have to create one more signal. Okay, and because it is time reversed, we will denote it as x of minus t. So this is actual x of t, this is actual x of t, and this is x of minus t because it is time reversed. Now what you have to do is that we have to add these two signals, the original signal and the time reverse signal. So when we add, you will get a signal like this. Okay, why it is so? Let us call this signal as the first signal and this signal as the second signal. You can see that the value of the first signal at this location is 0. However, the value of the second signal at this location is 1, right? So when we add 0 and 1, you will get 1. So that is why this location is having the value 1, right? Now if I go to the 0th time instant, the value of the first signal is 1 and the value of the second signal is also 1. So when you add 1 and 1, you will get 2. Okay, and when you come to the last portion, ending portion of the signal, first signal, its value is 1 and the value of the second signal is 0. So when you add 1 and 0, you will get 1. And the slope in the left side and the right side will be appearing in the resultant signal like this. So because of that reason, the signal will be like this. So this is actually x of t and x of minus t, right? Now if you divide that result with 2, if you divide that result with 2, you will get a signal with the same height as the original signal. So you will get like this. So this signal has a height of 2. So if you divide that with 2, you will get a signal like this. The value of the signal at the at a time t is equal to 0 will be 1, and at this location it will have a value of 0.5. We can mathematically represent it as x of t plus x of minus t divided by 2. If you perform that operation, you will get the even signal or even part of the signal. We have constructed the even part of a signal x of t. Similarly, how to construct the odd part of the signal? Again, you have to perform an operation, that is time reversal, x of minus t. So this is the time reversed signal, and what you have to do is that you have to subtract the second signal from the first signal. So the subtracted result will be like this. So let us see why it is so. Okay, so let us call this as first signal and this is second signal. The first signal has a value 0 here and the second signal has a value 1 here. So 0 minus 1 will result in minus 1. Okay, so this is minus 1, and at the center you can see this is 1, this is 1, right? So 1 minus 1 will be 0, and here you can see at the ending portion of the first signal it is having a value 1 and the ending portion of the second signal is having a value 0. So 1 minus 0 will be 1, right? The slopes will appear in the signal like this, right? So since it is subtraction, the opposite effect will happen and you will get the signal like this. This signal has a vertical anti-symmetry because this portion going upwards and this portion going downwards, and this is going downwards and this is going upwards. So because of that reason, we can see this signal has a vertical anti-symmetry, and if you divide that with 2, you will get a signal like this, right? And the amplitude will be equal to 0.5 because the amplitude of the signal is 1. Since we are dividing it with 2, you will get a signal with a 0.5 and minus 0.5 here. So we will get a signal like this. So this is the odd part of the signal x of t. Otherwise we can say x of t. Otherwise the odd part of the signal is equal to x of t minus x of minus t divided by 2. So this is how you can construct the odd part of the signal from the actual signal x of t. Now in the previous properties we have got signal that is the even signal and odd signal. What we have done, x of t plus x of minus t divided by 2, right? This is one operation we have performed, and the second operation is x of t minus x of minus t divided by 2, right? So this resulted in even part, and this resulted in odd part, right? And what happens if I add this even part and odd part together? See, I take the even part and odd part together and I add both of them. So what happens in the result, right? So we can see that we will get back the original signal x of t. Why it is so? We can see that this point is actually 0.5, right? So this is actually 0.5, and here it is minus 0.5. So if we add 0.5 and minus 0.5, you will get 0 here. And here it is 1 and here it is 0. So you add both, you will get 1. And here it is 0.5 and here also it is 0.5. When you add, you will get 1, right? And the slopes also will appear in the result, right, because of addition, and you will get the output signal like this. Actually this is the actual signal x of t where we have started. So by adding the odd part and even part, we can get the original signal back. Otherwise we can also say that a signal can be represented as a sum of the even part and odd part. See, the signal x of t can be represented as the sum of an even part and odd part. Here the even part is this signal and the odd part is this signal. So if you add this even part and odd part, we can get back the original signal x of t. So we have seen how to construct the even part of the signal from the original signal using this particular mathematical formula, and how to construct the odd part of the signal using this particular mathematical formula, and what happens if we add this odd part and a even part. You will get the original signal back. The area of even and odd signals. Even signal, right? So you can see that the even signal has a vertical symmetry. Whatever value at the positive time axis will be equal to the value in the negative time axis. Because of that reason, this area will be equal to this area. Both of them will be added together, and this area, okay, is a negative area. Here also a negative area. So they will be added together, and here it is a positive area. Here also this is a positive area. They will be added together, and this is a negative area. Here also a negative area, and here this is a positive area. Here also a positive area. Now we can see that since they are equal, it is not necessary to find the area from negative a, let us say negative a to 0, because whatever area from negative a to 0 will be equal to the area from 0 to a. So because of that reason, we can write the formula like this: area from minus a to plus a of an even signal x of t will be equal to 2 times. See, because why it is 2 times? Because if we find the positive area, that will be equal to the negative area, right? So 2 times 0 to a. So you have to see that the limit of the integral has changed. It is from 0 to a x e of t dt, right? So for an even signal, it is not necessary to find the area from minus a to 0. Instead, we can simply find 0 to a, and you can multiply that with 2, will give you the total area. So please remember that here the integration is used to find the area under the curve or area under the particular signal. So this is the case of an even signal. So what about odd signal? So the odd signal will be like this. It has vertical, please remember that it has vertical antisymmetry. So whatever negative area is there in the left side will be having a counterpart in the positive area. So these two areas marked in pink color are equal. Similarly, this portion, okay, so this particular portion is having a positive area, but the same will be cancelled by this negative area in the right side because they are vertically anti-symmetric, and this area will be cancelled by the positive area here, right? And similarly, this positive area will be cancelled by the negative area here. Similarly, the negative area here will be cancelled by the positive area. So if you find the area from minus a to plus a, in the case of an odd signal, you can see that they both will add together and they will cancel each other. So this will cancel this one, and this area will cancel this one, this area will cancel this one, this area will cancel this one, and this area will cancel this one. So if we integrate the total area of an odd signal within the range minus a to a, right, here also the integration is used to find the area under the signal or curve. So area under the curve x o of t dt is equal to 0. So the area of an odd signal within the range minus a to plus a is equal to 0. Here the question is derivative of an even signal is even or odd. So we can either prove it mathematically, or you can consider some examples of even functions and odd functions to prove this. So let us take an example. Y is equal to x power 4. Assume that a signal has this particular shape of the function y is equal to x power 4. Now what is the derivative of x power 4? It is 4x cube. Okay, so from this we can clearly see that this polynomial has a power 4. So this is an example of an even signal, and this particular signal has the power 3. So this is an example of an odd signal. Okay, so because of that reason we can say that derivative of an even signal will be equal to an odd signal. And similarly, take the example of a function y is equal to x cube. Assume that the signal has this shape y is equal to x cube, and what is the derivative of x cube? It is 3x square, right? So from this clearly we can see this is having a power 3. Okay, so this is an odd signal, right? And this derivative is having a power of 2, so this is an even signal. Okay, so we can conclude that derivative of an even signal is an odd signal and derivative of an odd signal is an even signal. We can prove this mathematically also. Consider x of t is equal to x of minus t. X of t is equal to x of minus t. So what is meant by that? Here this is an example of an even signal because the condition of the even signal is satisfied here. X of t is equal to x of minus t. Now take derivative in LHS and RHS. Here you can see dxt by dt. Here it is dx minus t by dt. Since the derivative is with respect to t, you have to put a minus here, right? And clearly you can see from here that here it is x of t, here it is x of minus t, and there is a negative sign in front of that. So clearly this indicates that this particular derivative result is satisfying the condition for an odd signal. If the signal is an even, then the derivative of that even signal will be an odd signal. Similar proof we can have for odd signal also. Consider the signal here. Here you can see x of t is equal to minus x of minus t. So this particular relation clearly shows that this signal satisfy the conditions for an odd signal, that is x of t is equal to minus of x of t. Now if you take the derivative in LHS and RHS, you can see that here it is dxt of dt, that's not a problem, but here minus of dx minus t by dt. So this minus and minus will get cancelled here, right? This minus and minus will get cancelled here, and finally you will get dx of minus t by dt. So this clearly shows that here it is an x of t and here it is x of minus t. Indicates that this is an even signal. If a signal is an odd signal, then its derivative will be an even signal.